Hi students, good morning. Welcome back to our physics class. Yesterday I have discussed about relative velocity in 1 and 2 dimensional motion. Isn't it? What is relative velocity? When two objects A and B are moving with different velocities, then the velocity of one object A with respect to another object B is called relative velocity of the object A with respect to B. Then we have discussed some special cases when two velocities are in the same direction, when it is in the opposite direction, when the two velocities are at an angle, etc. Also, I said to do the problems 2.27, 2.28, 2.29, 2.30. I think you have completed these problems. I hope you have understood that. Then, accelerated motion. What is meant by acceleration? Whenever there is a change in velocity, acceleration occurs, isn't it? So the velocity of the object is no more constant but changes with the time. Such a motion is said to be an accelerated motion. Then two types of accelerated motion we have discussed, that is uniform accelerated motion and non-uniform accelerated motion. What is uniform accelerated motion? If the change in velocity of the object per unit time is same or constant. Change in velocity per unit time is constant is known as uniform acceleration. If the change in velocity per unit time is different at different times, then the object is said to be moving with a non-uniform accelerated motion. Also, average acceleration, that is the ratio of change in velocity over the time interval. So average acceleration equal to delta V by delta T. Then instantaneous acceleration. So instantaneous acceleration or acceleration of your particle at time t is given by the ratio of change in velocity over delta t as delta t approaches to 0. That is acceleration a vector equal to limit delta t turns to 0, delta v by delta t is equal to dv by dt. Acceleration is positive if its velocity is increasing and is negative if the velocity is decreasing. So the negative acceleration is called retardation or deceleration. The negative acceleration is called retardation or deceleration. Acceleration is also a vector quantity. Its unit is meter second raised to minus 2 and dimensional formula m power 0 L power 1 t power minus 2. In terms of components, we can write a vector equal dvx by dt I cap plus dvy by dt j cap plus dvz by dt k cap. So this is the component of instantaneous acceleration ax, ay, az. Students, you have to understand that velocity is the first derivative of position. Velocity is the first derivative of position, that is v vector equal to dx by dt I cap in one dimension. So v is equal to velocity equal to rate of change of displacement. We can say first derivative of position vector with respect to time. Similarly, acceleration is the first derivative of velocity. So a vector equal to dv vector by dt. Rate of change of velocity is acceleration. We can say acceleration is the first derivative of velocity. d by dt means derivative in terms of differential calculus. Also, we can say acceleration is the second derivative of position vector with respect to time. That is, a vector equal to d by dt of b vector is dx by dt. So we can write dx by dt into I cap. This can be written as dx, d square x by dt square. So acceleration is the second derivative of position vector with respect to time. That is a vector equal to d square x by dt square into I cap. This you have to understand. Acceleration is the first derivative of velocity but second derivative of position vector with respect to time. That is a vector equal d by dt of dx by dt. Substituting the velocity, then we can write d square x by dt square. Yesterday, I have discussed one graph. That is position time graph and velocity time graph. Graphically, when the position time graph is given, the slope of the graph gives the velocity. The position and time, the graph varies between position and time. That graph is known as position time graph. The slope of that graph gives velocity. Also, the velocity time graph, in that the displacement can be obtained by taking the area under the curve. In the velocity time graph, area is equal to the displacement. Finding the area is equal to the displacement. In the same graph, when we are taking the slope, that will give the acceleration. So in the velocity time graph, when you are taking the slope, that is dv by dt, dv by dt, that is equal to acceleration. Also, acceleration time graph. In the acceleration time graph, the area gives the velocity. Area under the curve gives the velocity. This concept also you have to keep it in mind. Graphical concept. Position time graph, slope gives velocity. Velocity time graph, slope gives the acceleration, area gives the displacement. Acceleration time graph, area gives the velocity. A equal to dv by dt. A equal to dv by dt. From this we can write dv is equal to a into dt. dv is equal to a into dt. Hence we can write, that is finding the integral, integrating on both sides. So integral dv is equal to integral a dt. This is integration dv. Integral dv is giving v. Integration of dx is equal to x. So integral dv is equal to v. That is equal to integration a dt. Here already we have learned the integration is the area finding process. So integration of a dt gives the area. Okay, with respect to time t1 to t2. Today we are going to learn an important topic, that is equations of uniformly accelerated motion by calculus method. Equations of uniformly accelerated motion by calculus method. Consider an object moving in a straight line with a uniform or constant acceleration a. Consider an object moving in a straight line with a uniform or constant acceleration a. What is constant acceleration? The change in velocity per unit time is same. It is constant acceleration. Let u be the velocity at time t equal to 0. That is initial velocity. V be the velocity of the body at time t, later, at time t. Let's find the equations of motion. Already you have learned these equations of motion. B equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. Isn't it? Yeah. That equations we are learning by calculus method. We are using integration, differentiation, and we are getting that relations. First one, velocity time relation. Velocity time relation. That is, we are going to obtain the expression v equal to u plus at. Here already we know acceleration of the body at any instant is given by the first derivative of the velocity with respect to time. A equal to dv by dt. Acceleration of the body is equal to the first derivative of velocity with respect to time. Isn't it? From this, we can write dv is equal to a into dt. dv is equal to a into dt. Integrating both the sides. Here, the condition that the time changes from 0 to t. Time changes from 0 to t. And the velocity changes from u to v. This is initial velocity, this is final velocity. Okay. When we are doing the integration, we have to put the upper limit and lower limit. That is from and to positions we have to mention. So, integrating this equation, integral dv from u to v. The velocity changes from u to v equal to integral a dt from 0 to t time with respect to time. So, for constant acceleration, we can write integral u to v dv is equal to integral 0 to t a dt. Now, integration of dx equal to x. This is the formula, integration formula. So, what do you mean by integration of dv? That is equal to v. So, we can write v. Integration of dv is equal to v, and we have to write the limit u to v equal to, here for constant acceleration, we can take this acceleration as outside the integral. So, a into integral 0 to t dt. Okay. So, here we can write a into 0 to t integral dt. Integration of dt is again t. Integration of dt is again t. So, 0 to t. Now, in this integration process, we have to put this limit. First, we should put the upper limit, then minus lower limit. When you are doing this integration, first we should apply the upper limit of this quantity, then minus lower limit of this quantity. Listen here, instead of this v, first to put this limit v, minus instead of this v, next put this limit u. This is the process. So, v minus u is equal to a into, here also instead of this t, upper limit is t minus lower limit is 0. So, we get the relation v minus u equal to a into t, or v equal to at plus u, or we can write v equal to u plus at. This is the velocity time relation. Once again listen, velocity time relation, we know a equal to dv by dt. So, dv is equal to a into dt. Integrating both the sides from time 0 to t, velocity u to v. So, integral dv u to v equal to integral 0 to t a dt. Integration of dx equal to x, that is the integration formula. Apply here. So, integration of dv is v, integration of dt is t. A is taken outside, constant. And apply the limit, that is uv and 0 to t. Limit, when we are applying, we have to put first upper limit, next lower limit. Upper limit minus lower limit. So, v minus u is equal to a into t minus 0. That is v minus u equal to at, v equal to u plus at. Next, displacement time relation. Displacement time relation. That is, we are going to obtain the equation of motion s equal to ut plus half a t square. Okay. So, here s is the displacement. We know that velocity of the body is given by the first derivative of the displacement with respect to time. Velocity of the body is equal to the first derivative of displacement with respect to time. S represents the displacement. From this, we can write ds is equal to what? V into dt. ds is equal to V into dt. Now, substitute V equal to U plus AT in this relation. In this, ds equal to V into dt. So, we get ds is equal to V into dt. Instead of V, we have to substitute U plus AT into dt. U plus AT into dt. Here, at time t equal to 0, the particle is started at the origin, and later time t, the particle displacement is s. The a acceleration is time independent, constant. Okay. Now integrating this equation on both sides. That is integral ds. The displacement is from the origin to s. So 0 to s equal to integral u plus at into dt. Here with respect to time, so we have to put the limit as 0 to t. Are you able to follow, students? Next, this can be written as integral 0 to t u into dt plus integral 0 to t at into dt. Okay. So, integral 0 to s ds is equal to integral 0 to t u into dt plus integral 0 to t at into dt. Again, what is the integration formula? Integral dx is equal to x. So, integral ds is equal to s and the limit. Here, integral u dt, this integration is with respect to time. So, u we can take it as outside. So, u into integral dt. Integral dt. Integral dt is t. We have to put the limit 0 to t. Plus a. A is constant. We can take it as outside. It is independent of time. And integral 0 to t, t into dt. Here, apply the limit. First upper limit minus lower limit. So, s minus 0, that is s equal to u into t minus 0. Upper limit minus lower limit for this. So, we can write t minus 0. So, u into t plus a into, what is integration of t dt? Already we have learnt. That is integration of x power n dx is equal to what? X power n plus 1 by n plus 1. Isn't it? Similarly, here we can write integral t dt is equal to, that is t power 1 into dt. So, we can write t power 1 plus 1 by 1 plus 1. So, we can write t square by 2. So, what is integral t dt? X power n plus 1 by n plus 1. So, we can write t power 1 plus 1 by 1 plus 1. So, t square by 2. So, apply this here. A into t square by 2 and the limit 0 to t. So, we get s is equal to ut plus, applying the limit as t upper limit minus lower limit is 0. So, we can get 1 by 2 a t square. This is the displacement time relation. Displacement time relation. Once again listen. Velocity is equal to rate of change of displacement or first derivative of the displacement with respect to time. Isn't it? So, here the displacement is s. V equal ds by dt. ds is equal to v into dt. Now, apply v equal to u plus at in this equation. We get ds is equal to u plus at into dt. Integrating both the sides, integral 0 to s ds. The particle starts from origin to the displacement s. So, integral 0 to s ds is equal to integral 0 to t u plus at into dt. Here, we can write u into dt plus at into dt. Now integration ds, s. Here u we can take it as outside, and integration dt is t. So ut plus a in the integration 0 to t dt. Upper limit minus lower limit means we get s minus 0 s u into t minus 0 t. So ut plus a into integration of t dt, that is integration of x power n dx is equal to x power n plus 1 by n plus 1. We can write t power 1 dt is equal to t power 1 plus 1 by 1 plus 1 t square by 2. So we are getting a t square by 2 0 to t. So when you are substituting this limit here, t square minus 0 square. So we will be getting only t square. S is equal to ut plus half a t square. Third, velocity displacement relation. Velocity displacement relation. That also you have learned, that is v square equal to u square plus 2as. Isn't it? Acceleration is given by the first derivative of velocity with respect to time. A equal to dv by dt. Here, this equation can be written by dv by dt into ds by ds. I am multiplying and dividing by ds by ds. This equation will not change. And I am rearranging these terms. That is dv by ds into ds by dt. Can I write like this? In this equation, multiplying and dividing by ds by ds, this equation will not change. Now, we are rearranging the terms. That is, this ds I am writing here, this dt I am writing here. There won't be any change. So, a equal to dv by ds into ds by dt. What is ds by dt? S. V. So, we can write dv by ds into ds by dt is v. Since velocity is the first derivative of the displacement. Velocity is the first derivative of the displacement. So instead of ds by dt we can write v. A equal to dv by ds into v. This equation we are solving in one of the method. Listen. Differentiation of v square. This is a method which is given to your book. Okay. Differentiation of v square. What is that? That is dy by dx. Y equal to x power n means dy by dx is equal to what? N into x power n minus 1. Similarly, d. Suppose y equal to v square. Y is equal to v square means we can write dy by dv with respect to v. That is n into. N in means here 2. 2 into x power. Here instead of x, v. V power n minus 1. 2 minus 1. So we will be getting 2v. Isn't it? So dy by dv is equal to 2v or dy is equal to 2v dv. Isn't it? So differentiation of v square we can written as 2v dv. Listen students. Differentiation of v square we can write as 2v dv. How it is getting? That is, we know that y equal to x power n means dy by dx is equal to n into x power n minus 1. Isn't it? Here y equal to v square. This is the function. So we can write dy by dv with respect to velocity. We can write n into n is equal to 2. So 2 into x power n minus 1. Here x is v. V power 2 minus 1. So we can write 2v. Isn't it? So differentiation of v square. Derivative of this v square is equal to what? 2v dv. 2v dv. From this, dv square by 2 is equal to what? V dv. dv square by 2 is equal to v dv. So this relation we can substitute in this equation. Instead of v dv, we can substitute dv square by 2. A is equal to, instead of v dv, 1 by 2 dv square divided by ds. This is one of the method for solving this term. Another method also there. This method is given in your book. Okay. So A equal to, instead of v dv, 1 by 2 dv square divided by ds. So integrating on both the sides. Before that, we can rewrite this equation as ds is equal to what? dv square by 2 into a. ds will come this side. So ds is equal to dv square by 2 into a. So ds is equal to dv square by 2 into a. Integrating this on both sides, we are getting integral ds is equal to integral 1 by 2a dv square. Here the limit is displaced from 0 to s. Displacement is from 0 to s, and the velocity from initial to final velocity u to v. Integration of ds is s minus 0 s equal to 1 by 2a constant, we can take it as outside, integral u to v dv square. Here integration and differentiation get cancelled. That means integration is the reverse process of differentiation. Integration is the reverse process of differentiation. So integration and differentiation will be cancelling. We are getting 1 by 2a into v square and the limit. So s is equal to 1 by 2a into first upper limit v square minus, instead of this v, u, lower limit u square. So 1 by 2a into v square minus u square. Now we can rewrite 2as is equal to v square minus u square, or else we can write v square equal to u square plus 2as. v square equal to u square plus 2as. Once again listen, velocity displacement relation v square equal to u square plus 2as. We know that a equal to dv by dt, multiplying and dividing by ds by ds, and rearranging the denominator terms. So a equal to dv by ds into ds by dt. A equal to dv by ds into, instead of ds by dt, we can substitute velocity. Velocity is equal to ds by dt. A equal to dv by ds into v. Now, instead of this v dv, we can substitute dv square by 2. That is, differentiation of v square is equal to 2v dv. From this, dv square by 2 is equal to v dv. Okay. So this we can substitute here. A equal to 1 by 2 into dv square by ds, and 2a equal to, ds is equal to 1 by 2a into dv square. Integrating on both the sides, integral ds is s, and here 1 by 2a is constant, we can take it as outside. Integration and differentiation get cancelled because integration is a reverse process of differentiation, only v square. And apply the limit v square minus u square, so we are getting v square equal to u square plus 2as. We can also obtain the displacement in terms of u and v. Let's see. First equation of motion is v equal to u plus at. Isn't it? From this, what is at? At is equal to v minus u. Substitute this relation in the s equal to ut plus half at square equation. Okay. Substitute at equal to v minus u. That is, s equal to ut into ut plus half at into t. We can write this equation as half at into t. Now, instead of this AT, we can substitute V minus U. So S is equal to UT plus half into, instead of AT, V minus U, again T. So UT plus half BT minus half UT. UT minus half UT, 1 minus half, half. So 1 by 2 UT plus 1 by 2 VT. That is, we can take the common term outside, 1 by 2 T into U plus V. Or else we can write S is equal to U plus V by 2 into T. So V equal to U plus AT, AT equal to V minus U. Substitute this in this equation. S equal to UT plus half AT square. This T square can be written as T into T. So instead of this AT, we can substitute V minus U. S equal to UT plus half VT minus half UT. So 1 UT minus half UT, half UT. Half UT plus half VT, we can write half into T, U plus V. That is, S is equal to U plus V by 2 into T. This also we can say as an equation of motion. So what are all the equations of motion? That is, we can call this as kinematical equations or kinematic equations. What are they? V equal to U plus AT, S is equal to UT plus half AT square, V square equal to U square plus 2AS, S is equal to U plus V by 2 into T. These equations are called equations of motion or kinematical equations of motion. This equation is valid only if the motion is in straight line with a constant acceleration. For circular and oscillatory motions and all, these equations are not applicable. Students, you have to learn this question, that is, derive the kinematic equations of motion for constant acceleration. Very important question. This is your book bag question. Derive the kinematic equations of motion for constant acceleration. At least 3 times write and practice in your notebook. Let's see equations of motion under gravity. That is some of the special cases. Equations of motion under gravity. Case 1. A body falling from height. A body falling from a height h. So consider an object of mass m falling from a height h. Assume there is no air resistance. Okay. This is a particular height from the earth's surface. Here one man is standing. He is dropping an object downward. This is the height h. Okay. So acceleration due to gravity, which is constant near the surface of the earth. G, acceleration due to gravity is constant near the surface of the earth. An object of mass m falling from a height h. So acceleration vector, how can we write? A vector equal to, that is equal to here acceleration due to gravity, G into J cap. We are taking the coordinate system like this. This is an x-axis, this is an y-axis. Okay. Here the downward direction is the positive y-axis. Why it is positive? As the acceleration due to gravity acting downward. Okay, acceleration due to gravity acting downward. So we can consider this as the positive y-axis. So acceleration A vector can be written as g into j cap. That means here x component of the acceleration is 0, z component of the acceleration is 0, only the y component of the acceleration is g. Let's take for simplicity ay equal to g. Ay equal to g. Let's write the equations of motion for this case. Body falling from height h. So we know that u is initial velocity here and v is final velocity. Then instead of a we should substitute g. Okay. So first equation is v equal to u plus at can be written as u plus gt. U plus gt. Second equation is what? S equal to ut plus half at square. Here instead of s we can write y because the displacement is, that is downward direction, we can choose as y axis. So instead of s we can write y. So second equation of motion can be as y equal to ut plus half at square, for that half gt square. Then v square equal to u square plus 2as can be written as v square equal to u square plus 2as, that is 2gy. So for this case 1, a body falling from height h, we have to apply the value a equal to g, s equal to y. So the equations of motion becomes v equal to u plus gt, y equal to ut plus half gt square, v square equal to u square plus 2gy. Suppose the particle starts from rest. Apply the condition u equal to 0. This equations can be changed as v equal to 0 plus gt and y equal to 0 plus half gt square. Then v square equal to 0 plus 2gy. Also the time t equal to t taken by the particle to reach the ground, for which y equal to h. So use this condition t equal to t and y equal to h in the second equation, that is y equal to half gt square can be written as h is equal to half gt square. H is equal to half gt square. From this t square equal to 2h by g, or t equal to root of 2h by g. So this equation tells that greater the height, the particle takes more time to reach the ground, because t and h are directly proportional. So when the height increases, t also increases. That means greater the height, the particle takes more time to reach the ground. Lesser the height, it takes less time to reach the ground. So we have written height equation, h is equal to half gt square, and time equation, t is equal to root of 2h by g. Let's find the speed of the particle. So we can take the relation v square equal to 2gy. Okay, v square equal to 2gy. Here substitute instead of y equal to h. So v square equal to 2gh, v equal to root of 2gh. V equal to root of 2gh, or we can say v ground. So this equation implies that body falling from greater height will have the higher velocity. When the height increases, velocity also increases. So greater height will have the higher velocity. So these three formulas try to learn for solving problems. Okay. When a body falling from a height h value h is equal to half gt square, and T is root of 2h by g, and V ground is root of 2gh. What is free fall? What do you mean by free fall? The motion of a body falling towards the earth from a small altitude, that is h is very less than r, purely under the force of gravity is called free fall. What is that? The motion of a body falling towards the earth from a small altitude, small height, purely under the force of gravity is called free fall, where r is the radius of the earth. R is the radius of the earth. This is a 2-mark question. Let's see the case 2. A body thrown vertically upwards. A body thrown vertically upwards. So a man throwing a ball upward. So it reaches particular height and coming towards the ground. Here, of course, we neglect the air friction and the mass of object m. The initial velocity we can take it as u. And the coordinate system, this is x-axis, this is y-axis, this is the ground. Here we choose the vertical direction as positive y-axis. So how can we write the acceleration? A is equal to minus g. G is actually downward, acting downward. Here we are throwing upward, so we can write A equal to minus g. Okay, now let's write the kinematical equations of motion. So first one, V equal to U plus AT. That can be changed as V equal to U minus GT. Instead of A equal to minus G. Second one, S equal to UT plus half AT square. This can be changed as S equal to UT minus half GT square. And third, that is V square equal to U square minus 2AS. Here, the velocity of the object at any position y. So we can write S is equal to y. So this equation can be written as V square equal to U square minus, V square equal to U square plus 2AS. So here V square equal to U square, instead of A minus G. So we can write here minus 2G instead of S, Y. Minus 2G, Y. So these are the kinematical equations when a body thrown vertically upwards. I think you have understood today's class. You have to learn these 2 long answers. That is, derive the kinematical equations of motions for constant acceleration. Also derive the equations of motion for a particle falling vertically and projected vertically. Learn well, students. Thank you.